In this video, we are going to talk about sequences. Sequences are ordered lists of things. They could be numbers, they could be letters. In green here, I have the even numbers, 2, 4, 6, 8, 10, and so on. This is a sequence of positive numbers. And here I have in red the vowels of the alphabet, A, E, I, O, and U. And so, like I said, a sequence is an ordered list of things. In this unit, we're going to be particularly concerned with ordered lists of numbers. But I just want to emphasize here that when you hear the word sequences, think ordered list. That's all it is. It's a list that is in order. And one other thing that I want to point out here is that a sequence can be infinite. As in the case of the even numbers, there are an infinite number of even numbers, and a sequence can be finite, as is the case for the vowels in the alphabet. This is a finite list. So an infinite list goes on and on, an infinite sequence goes on, and a finite sequence has a certain number that you can count of elements in it. Now, as far as sequences of numbers are concerned, we have two different types of sequences. One is an arithmetic sequence. I'm going to create a purple box right here, or purple line rather. So we have an arithmetic sequence. And arithmetic sequences are additive, and so each step in the sequence is added to get to the next step. So, for example, an arithmetic sequence would be 7, and then 10, and then 13, and then 16, and so on. You might see a pattern here. If we look at the difference in between each of these numbers, it's a difference of 3 in between each two numbers. And so I'm going to write in green here just to show that we add 3 to get from 7 to 10, and then we add 3 to get from 10 to 13. We add 3 to get from 13 to 16. And if we wanted to know what the next number was after 16, we would just add 3 to 16 and we'd find out what the next number is, which would be 19. Again, arithmetic just means that we are adding. We are adding between each number. And of course, we could add negative numbers, which would be the same thing as subtracting. And so we also have the inverse operation of subtracting or subtracting. Now, in terms of defining an arithmetic sequence, there are two things that we are concerned about. One is, what is the starting value for the sequence? What is the number that the sequence starts at? I'm going to put that in yellow here. So the starting value, or sometimes it's referred to as the initial value. The starting value for this sequence is 7. That's just where the sequence starts. So I'm going to say we have a starting value of 7. And the other thing that defines a sequence is what the common difference is, or I should say defines an arithmetic sequence, is what is the common difference? What are we adding or subtracting at each step? And so that is our common difference. And so with this sequence, our common difference is 3, because we are adding 3 each time. And I'm going to put plus 3 just to illustrate that we are adding 3 at each step here. Now here's another example of an arithmetic sequence. I'll write down here at the bottom. What if we have 3, -1, -5, -9, and so on? What would the starting value be here? Well, it starts from 3. That's the beginning of our arithmetic sequence. And what would the common difference of this sequence be? Well, it would be -4, because I'm subtracting 4 at each step here. 3 subtract 4 is -1. -1 subtract 4 is -5. -5 subtract 4 is -9, and so on. So here we have two examples of arithmetic sequences. There's another type of sequence that we care about, and that is a geometric sequence. A geometric sequence. And geometric sequences are like arithmetic sequences, but instead of adding at each step, we're going to do something different. Let's see if you can figure it out. So if I have a sequence that goes 3, 6, 12, 24, 48, and so on, what is it that is changing at each step here? What's the operation at each step that we're using to get from one step to the other? Well, we're multiplying at each step. And what are we multiplying by? Well, we're multiplying by 2. 3 times 2, and here I can put this in green here. 3 times 2 is equal to 6. 6 times 2 is equal to 12. 12 times 2 is equal to 24. 24 times 2 is equal to 48. And if we wanted to find out what the next step was, then we would just multiply by 2, and that would give us the next step in the sequence. One thing that I want to be crystal clear about here is that with both arithmetic and geometric sequences, we're doing the same thing at each step. It's not plus 3 and then plus 2 and then plus 1. It's always plus 3 here. And over here, it's not times 2 and then times 3 and then times 4. It's just times 2, times 2, times 2, times 2, and so on. So again, just like an arithmetic sequence is adding or subtracting, a geometric sequence is defined by multiplying. We are multiplying, or you can also think of it as the inverse operation, which is dividing. So multiplying or dividing. And so in terms of this sequence right here, we care about the two pieces of information. We care about the starting value. We care about the starting value, which is 3. Our starting value is 3. And we also care about our common, it's not our common difference, it's actually our common ratio. Common ratio. And our common ratio here is 2, because we're multiplying by 2 at each step. We have a common ratio of 2. Let me show you one more geometric sequence here. You can see if you can figure out what the pattern is. If I start off with 100, and then I have 10, and then I have 1, and then 1/10, and then 1/100th. What's the pattern here? Well, the pattern is that I'm dividing by 10 at each step. You could also think of it as multiplying by 1/10. 100 divided by 10 is equal to 10. And similarly, 100 multiplied by 1/10 is equal to 10. There's two ways to think about that. So that's another example of a geometric sequence. And the last thing that I want to point out here is that an arithmetic sequence, if we're adding the same amount at each step, that's akin to a linear function. Remember, a linear function goes up in a line, a straight line, and at each step, we're adding the same amount in the line, or subtracting. And a geometric sequence is akin to an exponential function. Remember, with an exponential function, at each step, we are multiplying by the same amount. And so the growth starts off relatively slow and then goes up faster and faster as we go. Or it could go down faster or slower and slower in terms of exponential decay. So again, these are sequences. Just think ordered list. And there are two types of sequences that we are concerned with in this unit. One is an arithmetic sequence where we're adding at each step, and the other is a geometric sequence where we are multiplying at each step.